Okay, so if we go in our out node, we can say instead of selecting objects, you can do is type rndr underscore star. So what that will do is will automatically select any object that starts with rndr. So if I now open this, you can see it selects all of our render objects. So that's why I've been calling everything rndr like that. So this is a good way to sort of make separate render nodes, and it's just super useful to sort of, well, do it like that. So now let's press render again. Let's just reload. Now it's going to load every object in our scene. So yeah, there we are. So we probably want to start maybe changing some samples now because this is obviously way too noisy. So we want to probably go over like what should we change. We probably need to change some extra AOVs as well. So let's go into our AOVs. Let's add some additional AOVs. And this is why is it not linked? Let's link it to 2. Right, so let's add one. Let's go add volumetric lighting. So it's going to be our volumetrics. So press render. Then we'll have our volumetrics in there as well. Okay, so let's go to our passes. So diffuse, well, that looks fine. Somewhat, well, there's still a little bit. Let's see, do we have depth of field turned on right now? Because we need to turn it on. Okay, let's disable depth of field. Because depth of field is, okay, so we're gonna increase our samples on individual things, but cannot really do that if we have depth of field, because depth of field will require us to enable the uniform samples. Okay, so there's a couple of things we need to do. So we have these bubbles. The bubbles will need motion blur. So let's enable motion blur already. Because it just looks weird without those. Go to bubbles. So go on there, redshift object, turn on deformations motion blur, and go on our redshift drop, go to redshift, motion blur, turn on motion blur, and just enable instances and particle motion blur. Let's reload. Maybe we want to keep it off for now, but you can see it takes quite a long time now to start up. Maybe we want to turn it back off while we crank on the samples. Okay, so now everything will start blurring, so you can see our bubbles will have motion. Okay, let's turn off motion blur again, because this is gonna make it slow to set the samples. So I'm gonna say leave it like this for now, and we're gonna turn it back on later. So motion blur turned off. So the thing it does before is the pre-patch where it does the irradiance point cloud. That's why it first makes some dots. So that's what I mentioned before with TGI. So it makes these dots and it sort of blurs them out. So that's the original pass that you see. Right, so let's go through this. So we have a render now. Maybe we can already do a snapshot maybe. Right, so let's go through our passes. So let's go look at diffuse. Diffuse looks pretty good actually. So I don't think we need any more diffuse samples. Let's look at reflection. Well, I mean, there's not that much reflection, but the reflection that is there looks somewhat decent. Refraction, just on these things, hard to judge. Maybe GI, yeah, there's a whole bunch of noise. So we definitely need more samples for GI. take a quick note. Specular looks okay. You don't have separate samples for specular. You generally do that on the lights itself. Subsurface scattering, quite noisy. All right, let's just maybe start cranking up some of our sample. And well, volumetrics are super noisy. Okay, let's pause this. Let's go into our ROP. Let's go into the samples. So we don't, what I explained before, what you don't want to increase this yet. This max samples is an override for all of the other stuff. You mainly use this to get like clean motion blur and clean depth of field. So we will be cranking it up later, but not yet. We go to sampling overrides. So you can also set samples on like either individual lights, individual materials, depending on how far you want to tweak stuff. But in our case, we're just going to use these sampling overrides. So again, diffuse looked fine, reflection looked fine, refraction looked fine, GI looked terrible, but let's tweak that later. Specular looked fine. Okay, subsurface scattering needs more. So let's go to subsurface scattering. Let's say the sample should be 256. Just for now, we can also increase it later. Let's volume. Let's say also, let's maybe put 512 because we have quite a bit of volume stuff. And then into global illumination, let's put brute force GI rays. So that's mainly probably where so that's the brute force GI that we have. So the primary GI engine. Let's put this to 256 as well. Just increase these samples. Right. So we did a snapshot of this. Now let's do another render and see what the other render looks like. So I'm just gonna press render. So let's close this. Press render and see what difference this made that we just did. Okay, so we're back. So it took 1 minute 30 seconds to render, but you can see this cleaned up quite a bit. So let's have a look at our previous render. So very big difference. That one was 43 seconds. So it's, I mean, about twice as slow, but looks 10 times as good. Let's do another screenshot. Let's see if we need to improve it somewhere, but I think maybe it might be good enough for now. So diffuse still looks good. Reflection, fine. Refraction still looks fine. Specular, fine. Subsurface scattering looks great. Volume looks great. So let's maybe enable our motion blur and depth of field right now. So let's go to another frame maybe. And then we're can talk a little bit about some denoising maybe. Let's go over here. Let's render this frame. So let's render and see what comes rolling out. Okay, so looks okay. Let's do another render. Let's enable the depth of field. So maybe with quite a lot of, with the power quite high. And let's also enable motion blur. So this is gonna probably introduce some noise. Let's see what it does. So we can already see that, well, there's noise here in the depth of field. There's noise in the motion blur, stuff like that. So that might be a case for something like some, to maybe add some denoising. So I'm gonna show you the denoising. Then I'm going to talk a little bit about the different types of AUVs. And then when we're done with that, I will move to my actual production scene to show you some other stuff that might have been different there, because obviously the production scene looks better than this, but production scene also was me, well, tweaking a lot of parameters for a couple of weeks. So, yeah, let's go into, let's go into denoising. So if you have Redshift 3, then you should have if you go to output, should be a denoise tab. So in a quite a new build, they introduced Altus, which is now free. It used to be paid, and there's also Optics, but Altus kind of produces better results. So let's just try with Altus, just single pass. It adds a little bit of overhead, but it's not that bad. So maybe let's do a new I'm also gonna turn down the displacement on the squid, by the way, because I don't really like the way that it's looking. Go to the squid. Right, something like that. Let's render, and then it should hopefully also clear up this depth of field here. Right, so let's render. Let's see what it does. Okay, so it almost finished the main pass, and now you can see the Altus door nosing will start doing its work. And now you can see first stage complete, and you can see it sort of didn't make a lot of difference, by the way, in this case, but you can see this was without denoising, this is with denoising. So it does clean up some stuff. It does also maybe smudge out some stuff a little bit, but in general, it's quite nice. It also denoises the AOVs a little bit. I have found some problems with it, but for now, let's just call this okay. So let's set up some new AOVs that we need. And then when we've set up all the AOVs that we need, I'm going to move to the actual production scene, talk you through some of the differences there. Then we're going to render a frame, and then we're going to composite the frame inside of Fusion. All right, so if we go into here, so there's a couple of more things that we need. So we have these AOVs. There are a couple more AOVs that I used. So we need we want a Z depth, which is basically a pass of the depth of the scene, which you can use for something like post depth of field, but also just for nice, making something look nice, like adding some fog, for example. Filter full. Yeah, this looks fine. Let's see what I had for my original settings for the depth of field. So let's go to my original scene. If I had some additional settings for the AOVs, where are the AOVs? There are the AOVs. So 150, so then I don't have to test that out. Right, so this is just the max depth, or the maximum depth of the scene. So we need that one. Another thing we're gonna use is crypto mats. So that's gonna add 2, so let's add 10. So what crypto mat is really cool. So in compositing, you can do a lot of stuff, like for example, like selecting, like grading objects or stuff. So what you first needed to do is to determine beforehand what you want to sort of make a mask for. So with CryptoMat, you no longer need to do that. You no longer need to determine beforehand what you want for for masks. It basically, you can say, make a CryptoMat and go to CryptoMat, and what type of CryptoMat do I want it to be? Node name, material name, object ID, or a custom thing. So I'm gonna make one for the node name. So this will be, then I get a mat for each individual node here. And I'm going to make another crypto mat, which is going to be for the materials. So then I can, having compositing, I have complete freedom to select, to create a mask for each material, for each object. So that's something I want. And don't forget, we also need to have the UV pass. So why is it not there? Yeah, so again, because we had a custom thing called UV pass, we need to add that on there as well. So that's all of the things that are correct. So we could now say like for our thing itself, we could put it to the frame range, have it be like that, and then we could and then we could render it out. Okay, so I'm now going to move over to my actual scene. So this is just the tutorial scene. You'll get access to this one, and I will also give you access to the actual production scene, which I'm going to move to now. Because in the actual production scene, of course, it looks different than this one. So let's just move over there, and then you can see some extra lights that I did, maybe some extra tweaks. We can render a frame there. And yeah, that will just be, I think, make more sense than keep 2 or 3 hours of tweaking on this tutorial to sort of match the lights, because that's just boring to look at anyway. So let's move to the actual production scene.